The first one, we always end up touching on AI.
Yeah.
There's a lot of research going on in AI in a variety of ways.
Yep.
And our first story was a story in Reuters that also had 2 Nature papers that were related to it.
Yeah.
The headline on this is China's DeepSeek says its AI model has hit a cost of just $294,000 to train. The sort of byline is in a paper that is likely to reignite the debate over Beijing's place in the race to develop AI.
Yeah.
This sort of cost, which is significantly lower than the figures that we see in the U.S. And I know we've talked about DeepSeek and all of this quite a bit.
Yeah. It's a crazy model. And the fact that the team like put out a peer review paper, no one else has done that in the field of AI. Like gone to Nature and put out, okay, this is how we trained, this is how we did it.
It is, it is
they're
very interesting.
They're actually, it's kind of crazy that China is setting the precedent for open science in the field of AI, right?
It is very interesting. And not only 1, but 2 papers in Nature main brand, not a Nature sub, sub
This
category.
isn't IEEE, this isn't even like, NeurIPS, this is Nature.
And, what I thought would be helpful, we're going to do sort of 2 aspects on this story.
Yeah.
Folks might have seen the DeepSeek news, earlier in the year when there was sort of a big outcry about it.
Yeah, they released in January, I think.
Yes.
And then all of our stocks failed.
Yes, it was a big deal.
Yeah.
But January wasn't the start of this great power war over AI.
Right.
And I thought it would be good to just go over a couple of beats on the sort of geopolitical context that this research paper kind of came out in.
Yeah.
And to sort of set the stage, right, there's an AI great power competition between the U.S. and China. AI, as we know it, has existed for quite some time, before all this generative AI stuff. But in the sort of recent context, we're going to start in 2017, where China launched its next generation AI plan, which said it was going to lead the world in AI by 2030.
They're famous for their 5-year plans.
Right. And the idea is U.S. has been the global hegemon forever. China's looking at a way in which it can sort of destabilize that control.
Yeah.
And Xi Jinping, leader of the Chinese Communist Party, said that advanced tech is the sharp weapon of modern states.
Yeah, it's true.
And as we've discussed, on this podcast previously, there is a very strong relationship between the military intelligence and national security apparatus within nation states and frontier technologies, AI just being one of those. And then in 2021, what was interesting is the U.S. National Security Commission on AI, which was chaired by the former Google CEO Eric Schmidt, warned that American dominance in AI was not guaranteed. So we already have this setup of that friction.
Wow.
Now, if we go into the Biden era policies, because the U.S. government, as we know, as it relates to technology innovation, is usually reactive as opposed to proactive.
Yes.
If we look at the internet as an example, they allowed innovation to happen, and then they put in a regulatory infrastructure after the fact. With AI, because of the popular conversation from the likes of folks like the richest man in the world, depending on the day, Elon Musk, really ringing the alarm on, AI safety, which has created this accelerationist, decelerationist dichotomy within Silicon Valley. The Biden era was the first administration to take policy in earnest in terms of AI specifically.
Okay.
And this started in August 2022 when Biden signed the CHIPS and Science Act, which many people have probably heard, the CHIPS Act.
Yeah, the CHIPS Act.
$250 billion bipartisan bill aimed at boosting U.S. semiconductor manufacturing and innovation. This dovetails with the re-onshoring of manufacturing conversation post-COVID. There was $52.7 billion in supplemental appropriations that was specific to semiconductor-related programs for 2023 through 2027. The idea being that it was also going to create guardrails preventing recipients like Intel and TSMC from expanding their advanced fabs in China. So we can see the theory of the case here was, can we create a choke point at the hardware level? Because these chips were viewed at the time as being the key aspect of the stack that was going to be the driver of progress and innovation.
And TSMC is in Taiwan, which is like now iffy if China's going to do something, right?
Correct. So, China's been doing a huge military buildup and training around this idea of we're going to take Taiwan.
Yeah, that's basically their thesis.
We're
right?
going to take Taiwan, and you don't want to be here when that happens.
Yeah.
To us, the U.S.
Yeah, yeah.
And so they're
scary.
There are a lot of layers to this. The Taiwan point's a really important one. Now, 2022, we're still in 2022. August, CHIPS Act drops. And then October 7th, 2022, the October 7th controls were established, which are export controls. Now, they named it this prior to the unfortunate October 7th of 2023, which is the Israel-Gaza conflict.
Right.
But at the time, this was a restriction on exports of specific Nvidia and AMD chips, the
H100s,
A100s, and the AMD MI250s, which basically meant this was the whole, we have a small yard, high fence, making it really, really difficult to get these sort of frontier chips.
Yeah, and the thesis was that like these chips are the future.
Yes.
And without these chips, you can't do shit.
Exactly. That was the theory of the case at the time.
Yeah.
As a small side note, it's interesting that almost just over a month later, on November 22nd, 2022, ChatGPT launched.
Ah, okay.
So all this conversation was happening prior even to the meteoric rise of the first real, production level LLM, generative AI, accessible to millions of people. And the growth curve, as we all know.
That ChatGPT was the moment where now everyone was like, oh, AI is here.
Yes. It's not just this thing people are saying and da-da-da-da. It's not theoretical.
I can literally chat with it.
Yes.
And it's like giving me amazing answers.
Yes.
Yeah.
Yes.
Yeah.
So now we're moving into 2023.
Right.
So throughout 2023, now the Biden administration is not only trying to create the choke points domestically, but now we're going out to our allies all across the world to sort of expand that tightening. So this included in the Netherlands with ASML, and in Japan with Nikon and Tokyo Electron, blocking them from providing China access to their lithography tools, which are used to actually build and generate these more advanced chips.
Yeah.
This was followed up by, in August of 23, Executive Order 14105, which now also restricted investment from U.S. investors into any China AI or quantum firm.
Okay, so they're just like effectively slowly like choking all pathways
for hardware innovation.
Yeah, for hardware innovation.
Innovation.
Okay.
Right? So while this was all happening in 23, interestingly enough, there was the very, very sort of public falling out of the founder or CEO at OpenAI, Sam Altman. So many folks may remember there was that huge board battle.
I forgot about. Yeah, dude.
He was ousted as CEO.
He was ousted.
Yes. Oh my God. And this was around OpenAI was a nonprofit. They were doing a lot of for-profit moves. They wanted to kind of rejigger their structure, and it kind of signified the realization across the Silicon Valley consensus that this thing was going to be bigger, more powerful, more impactful, more money generating than even they had predicted. It was happening quicker than they expected. So there was that power struggle.
Right.
Ultimately, the king returned to the castle.
Yeah.
And Sam Rhee got his position as CEO. But all this we've talked about so far has been the U.S. side.
Yeah.
So in 23, China's response, like what has China been doing as the U.S.
That's right. So we've been battling internally, so to speak,
and to sort of create this regulatory regime around access to chips.
Right. So what's China been doing?
So China had firms like Huawei introduce their own, what they call frontier chips. With the Ascend AI chip, as well as shocking the global community when SMIC released their 7-nanometer process for smartphone chips, which, again, the idea was TSMC has really had a monopoly on the 7, 5, and I believe 3 now nanometer chip sizes.
Their latest is 3, but like sub 10 was them.
And no one else could really do it. And that was like a really big bottleneck. And there's both operational reasons and proprietary intellectual property reasons why that's difficult. They also then had their other big conglomerate technology companies, Baidu, Alibaba, begin to put out their own ChatGPT type LLMs. So we had Qwen, we had ErnieBot,
But nobody really
no one really thought anything.
Really cared.
No one
right?
cared.
Yeah.
They were all trained on the cut down Nvidia H800 GPUs, which were still allowed to be sold to China, but they were massively sort of handicapped.
Yeah.
Interestingly, now we're sort of getting into 2024, which is more of the same. But we talked about the intersection of the national security state, the intelligence community, military intelligence, and frontier technologies.
Yeah.
And Mark Andreessen made this interesting note in a podcast where he basically was trying to call out the folks who are called decels, or the folks who are really heavy on AI safety.
Deceleration. Okay.
Yeah, the decelerationists who are saying, let's slow down, let's slow our roll.
Got it. Elon is a famous one.
Elon is arguably the most famous decelerationist. And Mark Andreessen's point was, if you believe that this threat is as existential as nuclear weapons,
sure,
you're still allowing these OpenAI employees to go to an unprotected, unsecured building in the same way that, not in the same way that like nuclear facilities are protected from a operational security perspective. Totally. So he's like, if you believe this to be true, the entire operating infrastructure of these companies needs to change.
Yeah. That's fair, actually. I never thought about that, but yeah.
It's a fair argument, right?
Yeah.
And in 2024, on June 13th, after all this board kerfuffle in 23, the former head of the National Security Agency and commander of U.S. Cyber Command, Paul Nakasone, was added to the OpenAI board, which was the first salvo in what I like to call the nationalization of the frontier models in the United States.
Got it.
Right now, the national security state has a seat at the table. Shortly after, OpenAI announced several projects with the Pentagon, the DoD around using it. So this is all background leading up to the Sputnik moment for China.
That was a big one.
Which is in January of this year, 2025, when the Chinese startup DeepSeek released their R1 model, which was claiming at the time ChatGPT 4 level reasoning. So this is like our best, most frontier. This is pre-ChatGPT 5, which we now have today in September, fully trained on Nvidia H800s.
Yes.
The not good chips.
The not good chips, yeah.
Using a mixture of experts' techniques for the training alongside with reinforcement learning at what we now understand to be a sub $300,000 training cost. Now, it's important to note the amount of money that Anthropic, OpenAI, Meta has raised to train Grok, to train their foundation models is in the order of tens of millions, hundreds of millions of dollars.
Yeah.
So this is in orders of magnitude
less.
Difference.
Yeah. And
so what we ended up creating by doing this choke point on the hardware side was, necessity is the father of invention or whatever, right?
Yeah.
China then said, okay, let's innovate on the training model and infrastructure to try to get the same efficacy
on the algorithms and the
algorithm
software.
And the software, not on the hardware. So this created a huge surprise from a lot of U.S. observers, because the consensus was, if we choke off the hardware, they got nothing.
Yeah.
And this totally blew that out of the water. So at first there was fascination, which was immediately followed by the national security narrative taking over.
Yeah.
An interesting point about what China did with DeepSeek was, it was also, if we exclude Llama, Meta's Llama, models, which are open source, open weights, but arguably weren't as competitive as R1. China was the first frontier scale open weight model.
Yeah. They just published their weights.
Right. Yeah. Which the point here is then you can take it and make it into whatever you want to. So the app for DeepSeek became the #1 most downloaded app globally.
Oh, I didn't know that.
It was then banned in India, Italy, Australia, Taiwan, because the national security narrative came in and it was like, this is a propaganda tool. It's a data siphoning tool.
Yeah.
Don't trust DeepSeek. But it strategically left out the point about the fact that you could download the model, run it locally, and change the weights however you wanted to. So with DeepSeek, if you tried to look up Tiananmen Square, you weren't going to get an answer.
Really?
Right. So they were,
classic,
doing a little bit on
of course,
on the information control, but it's open weights.
Yeah.
So if you want the Tiananmen Square answer, you can do it on your own. But
interesting. I see. Yeah.
The narrative really tried to avoid talking about that point. At the same time, people started calling OpenAI closed AI.
Yeah.
Because they had never had an open source model. They never had a research paper, a peer review paper around their process. So now this brings us to where we are today with these 2 new papers in Nature, which go a little bit deeper into how DeepSeek went through their process. And we'll sort of talk about this. But I think that background is important context to understand, like, why does DeepSeek matter?
Yeah.
Why is it uniquely different than ChatGPT, than Claude, than, Gemini, all these other models? And why is it important that they actually have a peer review paper? We always talk, a lot of the U.S. conversation around science research is, China's papers, they fake the data.
Yeah.
They're not really good. They're not where we are. And I think this has been a unfortunate viewpoint in the U.S. about China generally, not only with cars saying they just steal our stuff, also with this that is a little bit outdated.
It is, definitely.
We're seeing with cars, the best EV cars in the world are made by China. It's not arguable. They make them cheaper, faster, better, stronger.
Yeah.
Which we've now put tariffs on in order to say, don't look here, there's no problem. Ford is still the best. And AI is taking a similar, in terms of our posture, a similar political stance that China doesn't really know what they're doing. This is not really a big deal, blah, blah, blah. And I think we need to be careful about ascribing a narrative that may have been true 15, 20 years ago.
Yeah, that's certainly not true now.
That's certainly not true
We've
anymore.
covered Chinese research. We've covered the hexagonal diamonds that were first created by China. Everyone's been going after them.
Yes.
But 2 labs in China were going after them, and actually one of them succeeded, right? Like, and the proof is in the pudding.
Yes.
They made it. They have all the tests.
Right. And there's peer review paper. Again,
and it's out in Nature.
It's out in Nature.
Right.
And we always talk about, this and that. So now that we've given that context, let's talk about these 2 new papers.
Yeah. These papers are pretty incredible in the fact that they're the first peer-reviewed paper from a sort of premier AI large language model, right? You have, like, obviously ChatGPT, Gemini, Grok, all of these large language models, but they haven't actually published anything that shows sort of, I'm sure that the team at DeepSeek has kept some secrets to themselves, but the fact that they've actually gone out and published this peer review paper is, I think, quite a watershed moment for the AI community, right? Because they're trailblazing this idea that maybe AI is a part of open science, and maybe it should be out in the open, just like normal science, right? Where it's like, you, as a scientist, you find something cool or you make something cool, you put it out in a peer-reviewed paper, right? And you let experts actually talk back to you, and then, like, see how things actually work, right? You want to get into the nitty-gritty of it. In the technical details, this paper is quite interesting because it tells us some of the tricks that they used in actually making it possible to train something like DeepSeek on perhaps only H800s. Again, maybe not, right? There's always a possibility that they're not totally forthcoming.
Right.
But they've sort of laid bare some of their strategies. And I think that's quite interesting.
I want to actually just make 2 small context notes that I think are interesting here. One is that the founder of DeepSeek, his story is that the reason they ended up creating R1 was actually he was doing the trading, like financial trade, like finance trading.
Right. It was related to a hedge fund.
It was a hedge fund plan, and they were like, we want a more powerful model to utilize for. So it wasn't even their core. It was an outgrowth of another need. And then I want to talk about this open sourcing concept of, like, why China did why are they doing this open source, open weights move? There was an interesting, there's a podcast, the BG2 podcast, with 2 U.S. investors, Brad Gershner and Bill Gurley.
Okay.
And they've been talking about this a lot. If you look at China's strategy generally as it relates to, if you're in a world where the U.S. already has dominance in a lot of these technologies that are closed source, from a how do we remain competitive angle, this is actually what Facebook did by trying to have Llama be open, is the best thing you can do to battle closed source is to create an open source ecosystem
Right.
that now becomes competitive with that closed source, because you're going to then now get input from a wider array of experts that invest in your version of the future. And so for China, there was an incentive geopolitically to go open source, being a second mover, as the means by which to combat the closed source dominance of the US. So this DeepSeek model is not an isolated incident of China using open source as a way to backstab US's closed source dominance.
Yeah, there's like there's a strategy behind this.
That is a larger part of how China is trying to spread its influence across these areas in which the current West's control and buy-in is waning.
Yeah. I mean, I think they figure that like the world is a really big place. Okay? And these developing economies are exactly that, developing, right? They're getting bigger, people are getting more affluent, technologies there are going to start getting better and better, and they're going to require AI to keep up with the rest of the world, right? And maybe they don't want to pay whatever royalties, right, to these closed systems. I think it's really cool. And I think the idea that DeepSeek came out, right, with their model in January, I think it was also a watershed moment for the rest of the AI community in terms of finding out the efficacy of something like a pure reinforcement learning approach, okay, rather than some of the techniques that ChatGPT and these other firms had used, which was a supervised fine-tuning or this sort of human feedback reinforcement learning, which always requires a human in the loop.
Yes.
Right? What these guys did was kind of a pure reinforcement learning approach. And that's something that they've laid out in this paper in Nature, okay? The idea is that sort of traditional LLM reasoning models, what they do is they require human input in order to steer them towards the correct answer, right? In order to be like, okay, this was not quite what I wanted. This is what I wanted, right? There were a bunch of like Kenyans that were hired by OpenAI to basically do this, right? And I don't know how many, but like that was a whole thing back in the day. And you know, that's fine for that's fine, but it's quite expensive in terms of like getting human annotated chain of thought data and so on and so forth. But on the other hand, there's actually a disadvantage to using humans, because then you are limited to human reasoning. Okay? There could be other ways to reason about a problem that wouldn't quite occur to a human being, that perhaps if we gave the entire control to the machine itself, the machine could figure out on its own, right? So there's an inherent disadvantage that I think these guys at DeepSeek actually like latched onto, right? And they figured that what we could do is we could use a pure reinforcement learning strategy where there's a reward signal. So the way the reinforcement learning works is you've got your model, right? And then it tries to find an answer. This works for well-defined tasks where there's a right and wrong answer, and there's a really nice way to compare your answer to the right answer and figure out what a reward should be. A reward being, if my answer is closely aligned to the right answer, then I'm on the right track, and the strategy that I've been using is sort of on the right track. And otherwise, maybe I need to try a different strategy. It's actually very close to how neural systems work, right? We've studied reinforcement learning like at the biological level when it comes to like, you know, a rat trying to find cheese in a maze, right? We've literally gone into the brain and found that how at the nitty-gritty level, at the cellular level, how this stuff works. And now we're kind of translating that into the AI neural network space, the artificial neural network space. So if we use pure reinforcement learning, what that does is it bypasses human-labeled reasoning steps. And then we can actually explore just computationally the entire paradigm of how to solve a problem, which is, I think, very cool. So that's one of the things that's revealed by this paper, the fact that they used pure reinforcement learning. Okay. It was this autonomous exploration and a development of problem-solving strategies. And what you could see, and what they report in the paper, is you could see the network sort of use that RL technique, reinforcement learning, to get better at finding the right answer. So what they noticed is, for example, the length of the answers would get progressively longer because the neural network wanted to get better and better at finding that right answer in this large language model type of thing. They also had this thing called the aha moment, which is when I was like, oh, this is like working way better than we thought, which is when, you know, in the chain of thought, you can actually output the thought that this thing is doing, right? And the model would start using the word wait. That was never explicitly put into the training regime, okay? But what the model would start doing is, as it was thinking, if it was trying to get to an answer and it was like sensing that it was rushing things and just trying to get it done quickly, it would use this thing wait. And then it would backtrack and try to figure out if there's a better way to rethink what it had just thought and then keep going. That's like some meta level weird stuff, dude. Like that it's just using this word wait in the context that the word wait means wait, and let's try to figure out what we just said in a nice way. You know, I think that's kind of crazy to backtrack. And then so it developed these autonomous, sophisticated reasoning patterns to try to, you know, solve the problem. And it's no longer limited by the human guided approach. Right. Which
also has bias issues related to human reinforcement learning, because now if you have a bunch of Kenyans doing it, there's cultural differences, there's educational differences, and so you this is where people sort of have concerns about the Silicon Valley elite being the ones controlling the parameters and mind space that these models sort of have. So this is like a very pure play version that kind of abstracts away the need for, at least in some cases, for the human input to be such a big driver in how it determines answers.
That's right. Yeah. So that was the reinforcement learning part, right? Yes. Which is like, okay, that's a training strategy. They also had this philosophy sort of efficiency over everything, right? Because of what you talked about, where, you know, the powers that be, let's say, have crippled their access to hardware. So what can we do? We can innovate with algorithms and we can innovate with strategy. So there's a two-pronged approach that they at least revealed in this Nature paper. The first one is this idea of mixture of experts, right? This architecture where what you can do is have a giant model. The DeepSeek model itself is 671 billion total parameters, which is on par with some of the big ChatGPTs and things like that. I think ChatGPT 5 has like on the order of trillion or more, but some of the earlier models have hundreds of billions. So it's in the same regime. But when it comes to actually inference, the number of active parameters used is only 37 billion. Which is 20 times less than the total size of this network. Because what they're doing is they've got this sort of network on top that comes in the very beginning, and it's kind of a router. Okay? What it does is you've got this 600 billion parameter network, but if you ask it a certain question, there's only a certain subset of that network that would be very good at answering that question, and that becomes that 37 billion part. So they've implemented this router mechanism that takes in the prompt of whatever you put in, and then it sort of routes that prompt to a subset of the network, and now inference becomes faster. It becomes less expensive in terms of maybe you don't need an H100 GPU, right? Maybe you can do with that H800. That previous model, and you can actually like get a quick answer, and it'll be just as good. Right. So that's one of the strategies that they used. The other strategy that they used was during training, they had this idea of using a reward system. Right. In reinforcement learning, you have to have a way of sort of quantifying how much the reward is, and then steering the network towards getting more of that kind of reward, right? So the way that traditional LLMs have been trained is through this process called proximal policy optimization, okay? PPO. It's this idea that you have your policymaker, which is your LLM, that's like actually outputting the language that gets output whenever you do the chat.
Yes.
But then there's this thing on top, which is kind of like the critic model. And what that critic model is doing is it's during the training process, it is taking the output of the policy, which is the output of the model, and then it's trying to guess at what the reward is going to be. Okay? And then what you can do is you can use this critic model and the advantage that you get, the advantage being what is my guessed advantage at this particular strategy. That's what this critic model calculates. Mm-hmm. And what this critic model does is feed back that advantage to the big LLM mm-hmm. to tell it, okay, you're on the right track, mm-hmm. this strategy is working, or no, it's not working. Mm-hmm. Crucially, this is very expensive because now you've got two models that you're training, right? You've got two models, and as the LLM gets bigger and bigger, the critic model has to get bigger and bigger to try to figure out how to calculate that advantage in whatever scenario, whatever game you're playing, whether it's text generation, whether it's whatever, right? So if you've got a bunch of H100s, that's fine, right? If you've got billions of dollars of funding from random VC firms, that's fine. But if you're DeepSeek, that's no longer tenable. Mm-hmm. So what these guys did was they used a different strategy called group relative policy optimization. Okay. They don't have this second critic model that they're doubly training, right? They don't have this 2x parameter blow up. Mm-hmm. What they have is their original LLM, and what it's going to do is it's going to output a bunch of different answers. Okay? Let's say, for the sake of argument, let's say 10 different answers. And then what it's going to do is it's going to calculate the reward for each, which we can get because this is a reinforcement learning strategy. And there's going to be a mean and standard deviation. There's going to be a distribution that you can calculate about that 10 different strategies. Mm-hmm. There's going to be some that are above the mean, which means that that is better than those others. The whole idea is you're trying to get this idea of advantage. Which are the strategies that give me advantage and which are the strategies that don't? In the ones before, in the traditional LLMs, the ones that we're doing in the States and in the West, we've got this separate neural network that is calculating that advantage and telling the original one where to go. Here, the original one is coming up with different answers and then creating a distribution out of that and then figuring out, okay, I should go here to this part. Mm-hmm. Whatever I did here, that's what's good. Whatever I did here, that's what's bad. Because I came up with 8-10 different answers. These guys were bad. These guys were good. Yes. Right? So you don't need this second giant neural network to train. Mm-hmm. Right? So it's a really interesting strategy where you're choked by the hardware. Yes. But you're saying, okay, well, I've got a few tricks up my sleeve. Yes. Right? Yes. I think it's rather cool.
I think that this is an important, there's always, because of this nexus between nation states trying to accrue and maintain power and the importance of frontier technologies to that goal, we're always going to see policy impact how these technologies grow and progress. The Biden administration made a bet that hardware strangulation to China was the best path at creating advantage for the U.S. in the race.
And it was a well-informed bet, right? Because like everyone who had been doing AI thought that was the masterpiece, right? That the hardware was it. That's right. Ever since 2012, when AlexNet came out, and what they could do is actually use GPUs to train in parallel, and then just all of the mathematics of matrix multiplication and backpropagation could be done on GPUs. Yes. That's when it was. Ever since then, we've sort of taken for granted that GPUs are really what matter. But we've created good enough GPUs. Yes. That we've taken for granted that like the best GPU is always the best. Right. But actually the H800 is like a good enough GPU now. Yes. That it can do enough of the math. Yes. That now these guys can actually go and start
tweaking the knobs.
Yeah, start tweaking the knobs.
It's a really, the cost difference is crazy. The equivalence of efficacy of the models, given the cost difference, is even crazier. And it is going to continue to be this hardware software tension where do you innovate more? Where has the most aggregate value in terms of continuing to increase the power and efficacy of these models? It's going to continue to be a rolling story.
Yeah.
I think, again, to your point at the top of when we started this story, it is very interesting that for the amount of time, I remember using GPT-2 in my company trying to see, trying to gauge when is this stuff going to be ready for production years ago. And it is, the jury is not out yet on this journey to AGI and artificial superintelligence. Which of these two levers that we're pulling are going to create those incremental, because we've sort of seen the models are kind of starting to aggregate at a similar level of performance.
Yeah.
And the gains from your walled garden are becoming less and less.
Yeah.
And this is a classic battle in every technology revolution that's ever existed in terms of the tension between closed source and open source.
Yeah.
Open source has always been, all servers run on Linux. Linux is open source. Why is that?
Everyone uses Python.
Everyone uses Python, open source. And the theory of the case is when you open source, there's more of a distributed incentive to create security.
Exactly.
Because everyone wants it to work. You're having more viewpoints inputting into the system itself. And you're limited by your resources if you go closed source by your talent. The way in which in the US we deal with that is Facebook gives billion-dollar offers to the best AI researchers. But at some point, this is the forever tension in technology revolutions. And it's interesting to see it play out in this geopolitical sphere where the winner or the import of the battle is so high.
Yeah. The stakes are really high here.
It's really high.
Yeah.
And so great first story. I love the AI stories are always great because a lot of times people just talk about the end product. Mm-hmm. We haven't had a lot of research papers to talk about.
No, but it's kind of cool that we got a sort of look under the box to see how it all worked, and they were also forthcoming about some of the challenges that they had. Mm-hmm. Like they when they first started out with DeepSeek R1, which is the one that they didn't release, they were having this trouble where the output would be half Chinese, half English, right? So then what they did was they had cold start data, so it wasn't completely all blind reinforcement learning. What they did was they primed the model with human data, okay? Right. To actually sort of give it a running start and not have it from the very beginning start doing random stuff. Mm-hmm. So what you do is you can have a small subset of human labeled training data that creates a sort of neighborhood of parameters, mm-hmm. okay? Mm-hmm. Where the model sort of settles in on this neighborhood of where the numbers should be for all of these weights. And then you can fine tune it. And fine-tuning is a coarse-grained word because obviously a lot of training was done afterwards. But after that initial sort of don't do the stupid stuff mm-hmm. of half Chinese, half English. But then now get into the, how do you problem solve? Mm-hmm. How do you actually mm-hmm. make a really nice LLM? So they were forthcoming about some of their challenges, which I think is kind of interesting.
And again, it goes back to the sort of the narrative violation that the current CCP has put ourselves in, where in the US we're still viewing their operating system as what it was 20 years ago, but they are being nimble and understanding the changing environment and trying to reposition. Yeah. Again, you can argue that it's contrived or not.
Yeah, I mean, knowing China, of course there's stuff that we don't know about, right? Of course, probably DeepSeek is entrenched with the CCP. I'm just saying, I'm just saying it's probably true. But they're doing the work. They're publishing peer-reviewed papers. They're coming out with cutting-edge AI, and they're doing it without the H100s, or at least not with the kind of access that companies have in America. Perhaps they do have H100s from shell companies in Bhutan or whatever.
Which is one of the arguments. is that they've been doing this illicit market trading in order to get access to it. But the point is they don't even need it.
Yeah. It turns out people are now that this is out, they're going to try using these strategies now, and we're going to see if the rubber meets the road.
And since DeepSeek came out, Meta was already releasing open weight models,
Yeah.
and I think they've actually incorporated some of the mixture of experts
Right.
architecture into the Llama models.
I think people are taking this sort of reinforcement learning strategy very seriously
Correct.
too, where they're saying, okay, maybe I don't need a bunch of Kenyans to just keep annotating my
Correct.
outputs, right?
Correct.
Yeah.
And we now, just in the last month and a half, have an open source OpenAI model. And it is very
Right.
easy to argue that we would not have an open weights OpenAI model without DeepSeek R1.
Yeah. Yeah.
There was not an incentive for
No, why would they do it?
OpenAI to
Yeah.
do so, but they had to answer to investors and the competition, etc. Great
Yeah.
update here. We'll definitely be touching on AI more.